Hello and welcome to another video on vectors, and in this video it's going to be quite a long video and I'm just going to go through loads of different GCSE style questions all about vectors. Now all of these questions that I've got have been taken from Corbett Maths, so if you do want to follow along at home I've provided the link to all of these questions in the video description. So, as always, make sure you pause the video and have a go at these questions before I go through them first. Right, so let's go through this question number 1. In the diagram, OBDE and OAFG are parallelograms. And we're told that B is the midpoint of OG and A is the midpoint of OE. We're also told two of the vectors. We're told the vector OA, which is this vector here, that is equal to A, and the vector OB is equal to B. So there's quite a lot of information here, which we'll probably have to use. Now the first question says, express in terms of A and B the following vectors and give your answers in their simplest form. So the first one is the vector OC. So remember, always think about your start and end points. So we're starting at O and finishing at C. So we're starting here and finishing here. So we can't just draw a line from O to C. That pathway is blocked off. We can only take pathways that we know. So we can go from O to A. So let's do that first. So we can go from O to A, and then we're going to add on this vector here from A to C. So A to C. So what are these vectors in terms of A and B? Well, the vector OA, well, that's just vector A. So that is just vector A. And then the vector AC, well, this vector is the same as B. Although it's in a different position, the magnitude and the direction is exactly the same. So this vector here is vector B. So we're going to add on vector B. And notice we can't simplify this anymore, so this is our answer, A plus B. Okay, now let's look at vector BA. So we're going to start at B. Let's do this in a different colour. Let's do this in red. So we're going to start at B, and we're going to finish at A. So again, we can't just go straight from B to A. We have to take a diversion. So we're going to go from B to O. So that would be vector BO. And then we're going to add on vector OA. And that will take us to A. Okay, so what are these two vectors in terms of A and B? Well, the vector BO, that's in the opposite direction to this vector. So it would be negative B. And then we're going to add on this vector. Well, that vector is just A. So we're going to add on A. So our answer is negative B plus A, or just to make things a bit tidier, we can say A minus B. These two things are exactly the same. So if you did leave it like this, that's absolutely fine. Okay, let's go on to question 3, and I'm going to do this in green. So the vector DF. So this time we're starting up here and we're finishing down here. Now, although there's a line here, we don't know anything about what this vector is, so we can't take this path. So we're going to have to go down from D to C and then C to F. So we're going to go find the vector DC and we're going to add on the vector CF. Now, let's think about what the vector DC is. Now, we know the vector OA, well, that's A. Now in here, if we look at this line here, it says A is the midpoint of OE. So this is the midpoint of this line. So if this is A, this vector here is also A. And now if we know that this vector is A, we also know that this vector is A, because they are parallel and they're exactly the same length. So we're trying to find the vector DC. Well, DC is the opposite direction to our vector A, so it will be negative A. And then we're going to add on CF. And just like before, it says B is the midpoint of OG. So if this is the midpoint of this line, if this is B, this is also going to be B. And therefore, this is also going to be B. So to go from C to F, we're just going to add on B. So it will be plus B. And again, we can change the order. We can say that that is B minus A. Okay, now let's look at part B. It says show that vector EG and vector DF are parallel. So let's first of all draw these two lines in. So I've drawn our two vectors in, DF and EG. Now we need to show that they're parallel. Now whenever you're asked to show that two vectors are parallel, what you need to do is prove that one of them is a scalar multiple of the other. Now we already know what the vector df is. We know that the vector df is b minus a. So if we can find that vector eg is a multiple of b minus a, then we can say that those two vectors are parallel. So let's work out what the vector eg is. So eg, well, eg is going to go, we're going to have to go from e to o. So it will be vector eo, and then we're going to add on vector og. So what are these two vectors in terms of a and b? Well, vector eo, well, this is, if ae is a, then ea would be negative a, and then we've got another negative a, so that would be negative 2a. Negative 2a, and I've just realised I've forgotten to underline my vectors. So all of these should be underlined. That's me being a bit hasty. Okay, all of these letters should be underlined to show that they're vectors. Okay, so from e to o, that's negative 2a. And then from o to g, well, that's going to be plus 2b. So plus 2b. Or we can rewrite this as, if we put the b's first, this is the same as 2b minus 2a. Now, is this a scalar multiple of our vector df? Well, yes, it is. This is 2 times bigger, because we can write this as, we can rewrite this as 2. If we factor out a 2, this is 2 times the vector b minus a. And we know that the vector b minus a is df. So we can also say that this is 2 lots of vector df. Okay, and because it is a scalar multiple of df, then it is parallel. Those two lines, or those two vectors, are parallel. Okay, moving on to question 2. So we've got two regular hexagons with the centre being at O, and the larger of the hexagons is bigger than the smaller hexagons by a scale factor of 2. So it's twice as big. And we're told that OA, so this vector here is A, and OB, this vector here is B. Write the vector AB in terms of A and B. So the vector AB, we're starting at A and we're finishing at B. Let's write that down. So vector AB. Again, we don't know what this vector is, so straight from A to B, but we can take a different path. We can go down from A to O. So vector AO, and then if we add on vector OB, vector OB. Okay, so what are vectors AO and OB in terms of A and B? Well, to go from A to O, notice that's in the opposite direction to our arrow, so it will be negative A. And then from O to B, well, that's just plus B. It will be plus B, which we can rewrite as B minus A. Okay, I've just switched these two terms around. Okay, question B. Write the vector OG in terms of A and B. So O, we're starting here, and G, we're finishing here. So we're going to go from O to A, and then from A to G. So let's write this down. So vector OG is vector OA, plus vector AG, so AG. And again, I've noticed I've forgotten to put my lines. I've forgot to underline my vectors. I do apologise for that. You're probably shouting at the screen in annoyance. Right, what is vector OA? Well, vector OA is just A. So that is A. Let's make sure we underline it. Now, we're going to add on vector AG. What is this vector? Now, we're not explicitly told what it is, but we are told that this hexagon is 2 times bigger than the small hexagon. So if this distance is A, the distance from O to G will be 2A. So I could have just written 2A right at the very beginning, but if the whole distance is 2A, this distance here must also be A. Okay, these are the same. So it would just be A plus A, which is 2A. Okay, now question C. Write the vector OE in terms of A and B. Well, OE means we're starting here and we're finishing here. Now, I can see that this distance here is exactly the same as this distance, but it's just in the opposite direction. So I can see that our answer will be negative B. But remember, we can't take unknown pathways. So just to make sure that the answer is negative b. Let's go all the way around the outside, and if we do that, we should still get negative b as our answer. So I'm going to go from O to A. Let's write this down. So vector OE, well, that's going to equal vector OA plus vector AF plus vector AF. That looks like FG. Let me just do that again. Plus vector AF plus vector FE. I'm going all the way around the outside. So what are each of these vectors? Well, vector OA, we can see that that is just A. And now vector AF, which is this vector here, well, that is parallel to this line, but just in the opposite direction. So that's negative B. And then FE, which is this line here, that's parallel to this line, but also we're going in the opposite direction. So that would be negative A. And now we can simplify this. A minus A is 0, or just they cancel, and all we're left with is negative B. So we were right before, but I just wanted to make sure, because we weren't given a line here, so we can't take that route. We can only take known pathways, remember. Okay, moving on to question 3. OABC is a trapezium. D, which is this point here, is the midpoint of BC. And E, which is this point here, that is the midpoint of AC. And we're also told some of these vectors. Okay, I won't read them all out. You can see them on the diagram. And it's important to note that this diagram is not drawn accurately. So all the information that we have has been provided. We can't assume anything else. Right, now the first part to the question. Write these vectors in terms of A and B. And the first one is OB. So O to B. So we're starting here at O and we're finishing here at B. So how can we get from O to B? Well, we can go from O to A first of all. So OA, and then we're going to add on this vector from A to B. From A to B, and now we just need to write these in terms of A and B. So vector OA, that is 2A, will be 2A. And then vector AB is 4B. So it's plus 4B, and that is our answer. We can't simplify this anymore. So our answer is 2A plus 4B. Okay, let's move on to the second part. AC. So this time we're starting at A and we're finishing at C. So how are we going to get from A to C? We can't go along this line here because we're not told anything about these vectors. Okay, so we're going to have to take a different path. The path that I can see where we've got all of the information is down here and along here. So the first part of the journey will be from A to O. So vector AO. The second part of the journey will be from O to C. So that will be vector OC. So what are these vectors? Well, A to O, that's the opposite of O to A. So that's negative 2A. Negative 2A. And then from O to C, that will be plus 8B. Plus 8B. And we can rewrite it as 8B minus 2A. Let's put our lines underneath here. Okay, so either of these will be fine. And finally, our last part to this, AE, vector AE. So we're starting here and we're finishing here. Now, this is where it gets a bit more confusing, but let's first of all look at this third line. It says point E is the midpoint of AC. So this length here from A to E, that's half of AC. Now we already know what AC is. We have a look up here. We worked out what the vector AC is. So to work out AE, we can just take half of this vector. So we know that AE is a half of vector AC. Vector AC, because we know that this is the midpoint. So it's going to be a half of the vector that we just found out, AC. So let's write that down. So 8B minus 2A. So it's a half of this, and well, we can work this out if we just expand the brackets. A half times 8B, well, that will be 4B. And then a half times negative 2A, or that will just be negative A. So this is our answer. Now, the last part B to this, it says show that vectors ED and OC are parallel. So just like before, to show that two vectors are parallel, one needs to be a scalar multiple of the other. So first of all, let's work out what the two vectors are. So ED, let's work out what vector ED is. So let's do it up here. ED. So we're starting at E and we're finishing at D. So how can we get from E to D? Well, we could go from E to A. So we can go from E to A, and then we can add on A to B, so vector AB, and finally we can add on vector BD. Okay, now there's a bit more to do here at the moment, we haven't quite finished. So EA, what is EA? Well, we know what AE is, vector AE, so we just need to take the negative of this because we're going in the opposite direction. So if we take the negative of this, it will be negative 4B, and then it will be plus A. So that is EA, vector EA. Now let's look at AB. Well, we know what AB is. AB, vector AB is 4B. So we're going to add on 4B. And finally, we need to add on BD. Now, what is vector BD? We're not really told any information about this. What I can see is if we look at this point now, this bullet point, we know that D is the midpoint of BC. So if we can work out what BC is, we can just take half of that value. So I'm going to add on a half of vector BC. But the thing is, we now need to work out what BC is because we haven't done that yet. So let's just copy, I'm just going to copy all of this down first. So we just need to work out what vector BC is. Now, BC, we're going to start from here, and finish over here. So we're going to have to go all around the outside. So we're going to go from B to A, and I'm not going to write down BA, I'm just going to write down what the vectors are. So from here to here, that's going to be negative 4B. And then from A to, let's underline that. From A to O, that's going to be negative 2A. And then from O to C, that's plus 8B. Plus 8B. So what I can see in our brackets, we can simplify what's in our brackets. So negative 4B plus 8B, well, that would just be plus 4B. So if I change that to a plus 4B, and then if I just get rid of this. Okay. And now let's expand the brackets. So let's first of all copy all of this out again. So we have a half times 4B, well, that is plus 2B. And then we have a half times negative 2A, or that is just negative A. So this is our vector. Now we're almost done, but we can simplify this. So if we collect like terms, well, we've got A minus A, well, those two A's will just cancel out. And we've got negative 4B plus 4B, well, those terms will just cancel out. And all we're left with is 2B. So after all of that hard work, our vector ED, so this vector here, is simply 2B. Right, now we had to do all of that. Now we can see what vector OC is. So OC, let's just copy that down. We know that vector OC is 8B. So are these two lines, or are these two vectors parallel? Yes, they are, because we can see that vector OC is a scalar multiple of ED. So we can just finish this off by saying that vector ED, well, we can see it's 4 times bigger. So it's 4 times vector OC. So we have proved, or proven, that these two vectors are parallel. Question 4, DFG is a straight line. We're told that DE is 4A, the vector DE over here is 4A, and the vector EF, which is this vector, is 6B. Write down the vector DF in terms of A and B. So DF, we're starting here and we are finishing here. So let's write this down, vector DF. Well, DF is the same as DE, the vector DE, plus the vector EF. That's the vector EF. So what are these vectors in terms of A and B? Well, DE is 4A, that would be 4A. And then EF is 6B, so it would be plus 6B. So that was nice and easy, that one. So that's our answer, 4A plus 6B. Right, now the second part says the ratio of DF to FG is 2 to 3. So what that means is if this was 2 centimeters, this part would be 3 centimeters. Okay, the ratio is 2 to 3. So if this was 4, this would be 6, for example. And now what we need to do, it says work out the vector DG in terms of A and B and give your answer in its simplest form. So DG, we need to work out what the vector DG is. So we know the vector DF, we just calculated that, and we can see that DG is parallel to DF because they are on the same line, so it has to be parallel. So DG is just a scaled up version of DF. Okay, so how many times bigger is DG compared to DF? So how many times bigger is this line compared to the shorter line? Well, the shorter line, let's say that is 2 centimeters. The longer line is not 3, it's going to be 2 plus 3 because we're interested in this whole line here, which would be 5. So if this length is 2, this whole length is going to be 5. So how many times bigger? Well, it's 2.5 times bigger. So it's 2.5 times bigger than DF. So we can say that it is 2.5, or I'm just going to use 5 over 2 as a fraction, just because I prefer dealing with fractions. So it's 5 over 2 times bigger than DF. Okay, and obviously we know what DF is. So it's going to be 5 over 2 times this vector here. So 4a plus 6b. So now we just need to evaluate this. So 5 over 2 times 4, well, that would be 4 divided by 2 is 2, 2 times 5 is 10, so that's just 10a. Plus 5 over 2 times 6, well, that would be 15b. So that is our answer, 10a plus 15b. Question 5, ABCD is a trapezium, and A and B and D and C are parallel. So these two lines up here are parallel. Well, they have to be parallel because it's a trapezium. And we're also told that DC, so this length here is 2 times AB. So it's 2 times this. Well, we can already work out what the vector DC is because we know it's 2 times this. So this vector here is going to be 2 lots of 3b, so that is 6b. So we've actually answered the first question already. It says write down the vector DC in terms of A and B. So let's just write it down anyway. DC is going to be 2 lots of 3b, which is 6b. Right, moving on to part B. Work out the vector BC in terms of A and B. Give your answer in its simplest form. So we're starting here at B and we're finishing at C. And again, we cannot go straight from B to C. We have to take the long way around. So we're going to use a lot of petrol this time. So to go from B to C, we are first of all going to have to go from B to A. So that's going to be vector BA. And then we're going to add on vector AD. Vector AD. And finally, we're going to add on vector DC. Vector DC. Now, I do appreciate that you don't have to write all of these endpoints in. You could just write down the vectors, vector labels straight away, but I'm just trying to cover all bases and just doing every single step. So, first of all, what is vector BA? Well, it's the opposite direction to this vector, so it's going to be negative 3b. And then vector AD, again, it's the opposite direction to this arrow, so it's going to be the negative of this. So it'll be negative b plus a, so minus b plus a. And finally, from D to C, well, that's just positive 6b. So let's simplify all of this. So let's start with the A's. We've just got 1a. We've just got 1a. And now the B's, we've got 6b minus 3b. That gives us 3b. Take away another b, we are left with positive 2b. So that is our answer, A plus 2b. Okay, question number 6. ABC is a triangle, and M, which is this point here, lies on BC such that BM, so this length here, is 4/5 of BC. So this length from B to M is 4/5 of the whole length. So if this part is 4, this part is 1. Or we could say this is 4/5 and this is 1/5 of the length BC. Okay, now we have to express these vectors in terms of x and y. So first of all is BC. So the first one, we're going to start here and finish here. So BC, well, we're going to go from B to A. So we're going to have vector BA, and we're going to add on vector AC. Vector AC, so we know what those vectors are. So vector BA, that's the negative of this. So it's negative y. And then AC is just positive x, so plus x, which we could just rewrite as x minus y. The order doesn't matter. Okay, let's move on to the next one, part B. So we need BM. So BM, we're starting here and we're finishing here. So we can see that BM is 4/5 of BC. So it's going to be 4/5 of BC. Well, we know what BC is, we just worked that out. So it's going to be 4/5 of x minus y, which is, if we just expand the brackets, it will be 4/5 x minus 4/5 y. So that is our answer. Right, okay, the last one. So part C, AM. So where's, oh, okay, A is over here. So we're starting here and we are finishing here. So usually, well, a lot of the time when you're solving vector problems, there's more than one route that you could take. I could go along this route from A to C and then C to M, or I could go from A to B and then B to M. I'm going to take the latter of those two options. So I'm going to go from A to B, first of all. So I'm going to do the vector AB, and then I'm going to add on the vector BM. BM. So what is the vector AB? Well, that's nice and easy. That's just y. And now the vector BM, well, we've just worked that out. We've worked out what the vector BM is. So we're just going to add on this. So we're going to add on 4/5 x minus 4/5 y. And now we can simplify this. So y minus 4/5 y, well, that's going to be 1/5 y. So we're going to have 1/5 y, and then we've got plus 4/5 x. Okay, I'm developing a very bad habit of not underlining my vectors. I do apologise. So I'm just going to, before I go any further, I will underline all of them. Okay. If I had a bold pen, then I don't need to underline them. But because this just looks like a regular typeface, they should be underlined. Okay, because we're differentiating between just variables and vectors. Okay, so because all of these are vectors, they should have a line underneath them. But I think we're good now. I don't think I've missed any off. Oh, yes, I have actually. These two here. There we go. Right, okay, let's move on to the last question. And here we go. Here's the last question, question 7. So AOB is a triangle. P is a point on OA, which we can see. A lot of the information given to us is redundant. So vector AB, oh, we're already told what vector AB is. So this vector here is 2A. Let's write that down. Vector AO, so this vector here, and this goes from A all the way up to O. So that is 6B. And we're also told that the ratio of AP to PO is 2 to 1. Okay, so this is 2 and this is 1. So if we write it as a fraction, this would be 2/3 and this would be 1/3. Okay, it's not drawn to scale, so even if it doesn't look quite right, it is right. So the question is, find the vector OB in terms of A and B. So the vector OB. Well, we don't know anything about this journey, but we do know something about this journey. So we're going to go from O to A. So OA, and then we're going to add on this vector, AB. So let's do both of those. So vector OA, well, we know AO. We know AO is 6B. So OA is just negative 6B. It would be negative 6B. And then AB, well, that is just plus 2A. Plus 2A. So that is our answer. And I always like to put it in an order where we don't have a negative at the front. So if we put 2A minus 6B. So that is our answer to part A. Now if we move on to part B, Q is the midpoint of OB. So this point here is the midpoint of OB. So this is a half and this is a half. These two lengths, they're equal. And B is also the midpoint of AC. So this is a half and this is a half. These two lengths are the same. Now we need to show that PQC is a straight line. So let's just draw the line in. It would be from here to here. Let's draw that line in. Now you can see that after I've drawn the line from P to C in, you can see that Q doesn't go through that line. But remember, this is only a sketch. Okay, so it is not drawn to scale. That's the really important thing to note. Now the key question here is, how are we going to prove that PQC is a straight line? Right, to do this, we first of all need to work out the vector PQ, and then we'll need to work out the vector QC. And now if those two vectors, or if one of the vectors is a scalar multiple of the other, then we know that they have to be parallel. And if they're parallel, they must be on the same line because they both go through Q. So first of all, let's work out what the vector PQ is. And now to get from P to Q, there's different ways we could get there. I think I'm going to go from P to O and then O to Q. So if we write this down, so vector PQ is going to equal vector PO plus vector OQ. So what is vector PO? Well, we can see that that's 1/3 of this vector AO. That's 1/3 of vector AO. So, well, we already know what AO is, so I can just write that in. So 1/3 of 6b. And then we're going to add on vector OQ. Well, OQ is a half of the vector OB, which we don't know yet, but we can work it out. So it's going to be a half of the vector OB. Right, okay, let's do our next line. So what is 1/3 of 6b? Well, that's just 2b. That would be 2b plus a half of vector OB. Well, OB, to go from O to B, we're going from O to A. So again, I'm just going to write in what the label, I'm not going to write in the endpoints now. So from O to A, that's going to be negative 6b, because we're going in the opposite direction. And then plus 2a, plus 2a. Right, so let's simplify this. So it's going to be 2b. Now if we expand the brackets, a half times negative 6b, well that's negative 3b. And then a half times 2a, well that's just plus 1a. And then our final simplification is going to be, we've got a, so if we get the a terms first, and then 2b minus 3b is just minus b. It's a minus b. So that is the vector PQ is a minus b. Now we need to work out the vector QC. So to do that, let's do that up here. So QC, and this does take a while. So QC, how can we get from Q to C? Well, we can go from Q to B and then B to C. So QB plus BC. So what is QB? Well, QB, again, a QB is a half. Well, actually, what I can do is I know that OQ is exactly the same as QB, okay, because Q is halfway between OB. So these two vectors are the same. So I can just use my vector from the previous question for OQ. So where was it? OQ was a half OB, which was, so I think all of this, yeah, all of this was the vector OQ. So I can just use all of that. So it would be A minus 3B. So that is the vector QB. And now what is the vector BC? Well, we can see that, again, B is the midpoint of AC. So this vector AB is exactly the same as this vector BC. So this is also 2A. So we're going to add on 2A. And now we just need to simplify. So A plus 2A, that is 3A. And then we've just got minus 3B. So we have found both of the vectors now. Now, the question is one of them a scalar multiple of the other? And the answer is yes. It's not always a nice relief to have that. So we can see that QC is 3 times bigger than PQ. So we can say that QC is 3 times A minus B. Okay, I've just factored out a 3. And A minus B is exactly the same as PQ. So QC is 3 times PQ. Oh, let's put our arrow in. And because it is a scalar multiple and they both go through Q, they must be on the same line. Now I've just put a summary here just to show you exactly what I've done. So I've said that as vector QC is a scalar multiple of vector PQ, and they both share a common point, which is point Q. So you can see that QC has Q in it and PQ also has Q in it. Then PQC must be a straight line. So we've come to the end of this long video on vectors, but hopefully you got a lot out of it and hopefully you're now a vector whiz. So thank you very much for watching. I do have one more video on vectors that I'm going to share with you, which is some slightly higher tier GCSE questions that can get a bit trickier, similar to this last one. So if you'd like to come along and watch that, please feel free. Otherwise, thank you for watching and I'll see you soon. Take care.